I almost forgot to make this video for you guys, but we had gone through all the examples on 2.1 on Tuesday. This was the last time I saw you all. Wow. And we did not get through example 6. So I'm going to go through example 6, and that'll complete our 2.1 notes. You have to forgive my voice. It's kind of scratchy. I don't know if it's from yelling at the ball game last night or if it's maybe I'm getting sick and dying. I've got coronavirus. Who knows? But before I get going, I want everybody to make sure that if they get the opportunity to congratulate Jade Neese. She was awarded a very substantial scholarship to Transylvania University, and provided that she maintains a 3.0 GPA, she'll get to keep that scholarship, which is fantastic. So I was really excited for Jade when she let me know about this, and I hope that you guys will share in her joy as well with her. So with this example that we're looking at, we're talking about supply and demand, and these two particular equations, the S of P gives the supply of the cell phones, and then the D gives the demand of the cell phones each month, and P is the purchase price. And what we want to look at is, for part A, is called the equilibrium. So the equilibrium is when the supply meets the demand, and so basically that's just when those two equations are equal to one another. So for part A, we're looking at S of P equal to D of P, and we could just set those two equations equal to each other. So S of P is 30P minus 900, and we're going to set that equal to negative 7.5P plus 2850. And then we're just going to solve this for P, which will give us the equilibrium quantity at any given price that we're looking for. So we'll add 7.5P to both sides. So we get 37.5P. Add the 900 to both sides, and that's going to give us 3750. And then we divide everything by 37.5. So we get a demand price of, let's see, that's going to be 100. So at $100, the supply and demand will be equal to one another. So that gives us the amount demanded or supplied at the equilibrium price, that gives us the the equilibrium price. Now, if we wanted to find the equilibrium quantity, we take that $100 and we put it into either one of the equations, because it will generate the exact same value, since that's when these two equations are equal to one another. So we have our price is $100. That's the equilibrium price. And we want to calculate now the demand amount, or the quantity of cell phones that will meet that particular supply and demand equilibrium. So let's just look at S of 100, which would be 30 times 100 minus 900. So we're going to get 3,000 minus 900, and that's going to be 2,100 cell phones will be the demand, and also the supply that at $100 where we reach the equilibrium. Part B says to determine the prices for which the quantity supplied is greater than the quantity demanded, which means we want to find the inequality S of P is greater than D of P. So for part B, it's S of P is greater than D of P. And in that case, we have 30P minus 900 is greater than negative 7.5P plus 2850. So we want to solve this again for P. We've already done that with an equation with the inequality. Our values are still going to be the same. So in this case, without having to do all the algebra all over again, whenever the price is greater than $100, the supply will exceed the demand because people are going to stop demanding the phones as the price increases. The lower the price is, the greater the demand, but then they have to worry about whether or not they can supply it at that price. Part C, graph the two functions on the same coordinate axis and label the equilibrium point. So I'm going to graph S of P using pink. So S of P equals 30P minus 900. Let's see, how do I want to do my labeling here? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I'll go by 500s on my vertical axis. This will be the number of cell phones. So 500, is that what I want to do? Yeah. 1,000, 1,500. And then across the x-axis is where we'll put our cost, or the price, and I'll start out at we'll say 25, 50, 75, 100. Okay, so there are my values. So when P is 0, my y-intercept is 900. And I have a slope of 30. So actually my y value is at negative 900. So that's going to be way down here. And then my slope is 30. So at $100, we know that it will be 2,100. So my graph will look something like this. We know this is the equilibrium point too, by the way. And then we want to graph D of P, that's the demand function. And that's going to be negative 7.5P plus 2850. So when P is 0, my demand is 2,850. Well, and then it goes down negative 7.5 for every $1 increase. And again, it's going to pass through the equilibrium point. So that graph will look something like this. And there's your demand. Supply is as supply increases, demand decreases. And that's kind of your mathematical model for example number 6. So I hope this clarifies or concludes any questions you might have on 2.1. Next time we meet in class, we're going to do a practical application of building mathematical models using some real-world data that I collected last semester for same class. And you guys are going to apply it, work with it a little bit, and then we're just going to keep moving forward. So hope everybody's had a great weekend, enjoyed your 4 days off, and I will see you on Monday.